Hi everyone, this is Algebra 1, Topic 7, Polynomials and Factoring. In this topic, we'll be able to think about the topic essential question. How do you work with polynomials to rewrite expressions and solve problems? We have 7 lessons in this topic. Some topic vocabularies are closure property, degree of a polynomial, degree of a monomial, difference of two squares monomial, perfect square, trinomial, polynomial, and standard form of a polynomial. So you might wonder, what is a polynomial? And we'll get started with that. Okay, so lesson 1 is about adding and subtracting polynomials. Let's look at 7-1, adding and subtracting polynomials. In this lesson, we'll be able to combine like terms to simplify polynomials. The lesson vocabulary that we'll be learning would be closure property, degree of a monomial, degree of a polynomial, monomial, polynomial, standard form of a polynomial. Let's start with explore and reason. Each year, the Student Council conducts a food drive. At the end of the drive, the members report on the items collected. If you look at the picture, there are some items. We have oatmeal, peas, meat, beans, corn, and rice. So describe 2 different ways that the students can sort the items that were collected. And then we'll write 2 expressions to represent the number and type of items collected. Share your expression with classmates. So let's get started with part A. Yeah, this is part A. And that's part B, and that's part C. So what are 2 different ways that the students can sort the items? We can sort the items like shown in the picture by their types, right? Vegetables, meat, grain, etc. Or what other category could we make for them? Maybe the type of container it comes in. Maybe cans go together and then the packages go together. Boxes could go together. What are other types? You can order them in prices, how cheap they are, how expensive they are for each. But yeah, let's describe 2 different ways. Here we go. Okay. And part B, write 2 expressions to represent the number and type of items collected. So now we're going to write expressions using variables to represent the number and type of items collected. So the first expression, we could talk about the numbers, right? So 1, 2, 3. So if we sort them by the types, we can count how many vegetables there are, how many meat there are, how many grains there are, and then add them up. If we sort them by the type of container it comes in, then we can add how many cans they have and how many packages they have. I don't see any boxes, so that would be just 2 categories. Why don't we sort by the type of container? Because I feel like veggie and meat and grain would be a little bit confusing. Thinking, where does oatmeal go? And is bean more of a protein or is it more of a grain? One would argue one or the other. So let's go to a less controversial type. Let's do cans and packages. So see how many peas there are. 1, 2, 3, 4, 5, 6. There are 6 cans of peas. 1, 2, 3 cans of meat. 1, 2, 3, 4, 5 cans of beans. 1, 2, 3, 4, 5, 6 cans of corns. 1, 2, 3, 4 packages of rice. And then let's do 4P and then 6C, 5C, 3C, 6C. and then 1, 2, 3 packages of oatmeal. So then you can write the expression 3p plus 4p plus 6c plus 3c plus 5c plus 6c could be our expression, and you want to write another expression to represent it. So you can add the like terms and say I have 7 packages total, and then 6 plus 3 is 9 plus 5 is 14 plus 6 is 20. 7 plus 20, 7p plus 20c. So 7 packages and 20 cans. Share your expressions with classmates. How are the expressions similar? How are they different? Why are they different? So some of your classmates may have sorted it by the type. How many veggies we have. You can count the number of peas. Wait, is that more of a grain? So yeah, categorize them. How many meat? How many beans? Yeah. So it could be different by cat. So you can say our expressions may use different variables, and the terms could be different with different coefficients because we classify our items differently. So classification is very important in writing your expressions. So whenever you use variables in real-world situation, what do you want to clarify? You want to clarify what your variables represent. Okay. So please make a note of what the variable represents. All right. The lesson essential question is, how does adding or subtracting polynomials compare to adding or subtracting integers? We'll see and compare those two. Are the rules different or are the rules mostly the same? Let's start with example 1. Let's understand polynomials. What is a polynomial? Why does a constant have a degree of 0? So here is one vocab. A monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. Okay, so 15x squared on the bottom here is a monomial. The degree of a monomial is the sum of the exponents of the variables of a monomial. Okay, so if you look at the powers, right? 15x squared is one term. It is a monomial. And the degree of a monomial is 2 because the power of the variable is 2. What about this monomial here? We have 1 over 2 as a coefficient, then x to the power of 5, y to the power of 2. Although the variables are different, this is one term because it's not separated by addition or subtraction. As long as they're all multiplication, this is one term, and this is monomial, okay? And the degree of a monomial is all the powers in total from any variable, okay? So x has a power of 5, y has a power of 2. So you add the degrees. 5 plus 2 is 7. So the degree of the monomial is 7. Degree of x would be 5. Degree of y would be 2. But degree of this monomial altogether is 7. Okay? So remember to find the sum of the exponents in each term, not just the greatest one of any variable. So another vocab you need to know. A constant has no variable. What is a constant? Just a number without the variable. However, any number to the 0 power is 1, so you can multiply a constant by x to the 0th power without changing the value of the constant. Does that make sense? X to the 0 power is basically 1. So 7 times 1 is 7, so that's a constant as well. So the degree of a constant is 0. The degree, the power of the variable is 0. Why do we want to do this? So that we figure out what the degree of the constant is. The degree of constant is always 0. Okay? So please remember these facts. Now that we've understood some vocabs and concepts, let's look at some questions. Why is 5x cubed minus 4 called a cubic binomial? Let's try to categorize our polynomials. Okay? What is a polynomial? A polynomial is a monomial, or the sum or difference of two or more monomials called terms. So need to remember the terms and that they are separated by sum or difference. So polynomials will have sum or difference between two or more terms or monomials. Okay, so monomials added together or monomials subtracted together, the whole thing is called a polynomial. And even one monomial also is categorized under the polynomial. Okay, polynomial just defines everything. A monomial is just a type of a polynomial. Okay, and constant is also a type of polynomial. Let's look at the degree of a polynomial. The degree of a polynomial is the greatest degree of any term of the polynomial. So now this is confusing because degree of monomial is what? Degree of monomial is the total degree in your monomial, in your term. Okay, you add the degrees, but that's a degree of your monomial. Degree of a polynomial is the greatest degree of any term, which means the greatest monomial degree in your polynomial would be the degree of the polynomial. So for polynomials, if they're separated, the terms are separated by addition or subtraction, you do not just combine all the degrees. You look at the degree of each term, each monomial, and whoever has the greatest would be the degree of the polynomial. Does that make sense? There is the difference. Okay. So let's look at this chart. Polynomial has very numerous types. Okay. So the first one, 7, that does not have any variable. It is a degree of 0 because it's a constant. That's the name. Okay. 4x, it has a variable, it has a constant. Together, it's a monomial. No addition, no subtraction, they're just multiplication. It's a monomial. And the degree, the power of x, it looks like there's no power, but if you have x, that means you have a x to the power of 1. Okay? X to the power of 0 is 1, so that's a constant. That means your variable is gone. So 4x is, it could be called linear, or this is called monomial, or it could be called term. Okay, one term. Let's look at the third one. 3x squared plus 2x plus 1. That is a polynomial. It has how many different terms? 1, 2, 3 different terms, 3 different monomials. And the degree of the polynomial is 2 because each monomial will have a degree of 2, 1, and 0 degree. The greatest degree is 2. Okay? And the name based on degree, the polynomial that has a degree of 2 is called quadratic. All right, negative 5x squared y. You have x to the power of 2, y to the power of 1. So the degree of the polynomial is 3. And this is also monomial. Okay, this is a monomial. You add the degrees, 2 plus 1, your degree is 3. And the polynomials that have degree of 3 would be called cubic polynomial. And then the last one, you see 4x squared, y squared. You can already tell that that has a degree of 4. 5x to the power of 1, so that's a degree of 1. Negative 2y plus 6, so that's a degree of 1 as well. 6 is constant, degree of 0. Altogether, 4 is the greatest degree. You do not add the degrees of monomials. This is just called a 4th degree polynomial. Okay? These are some names that we have for polynomials. Polynomials are also named according to how many terms they have. Okay? So just like I explained, 4x has 1 term, so that's called monomial. X plus 7 has 2 monomials. The number of terms would be 2, so it's a binomial. 1, 2, 3 terms, trinomial. 1, 2, 3, 4 terms, polynomial. So whenever you see addition, whenever you see subtraction, those are the signs that divide your terms, okay? If you have 1 addition or subtraction, that means you have 2 terms. If you have 2, that means you have 3 terms, and so on, okay? Negative doesn't count. It has to be subtraction or addition. All right, so then you have different names based on the degree and based on the number of terms. So remembering that, you can find one unique name for each polynomial. Okay, so for example, 5x cubed minus 4 is what would that be called? Based on degree, it has the power of 3, and degree of polynomial is 3, so it should be cubic polynomial. And also, how many terms does it have? 1 and 2. So it's a binomial. So together, it's a cubic binomial. All right. And also note that any polynomial with degree greater than 3 are named by their degree, like 4th degree, 5th degree, and so on. Okay, 4th degree binomial, 5th degree trinomial, and so on. Okay, so you say the name based on degree first, and then the name based on number of terms go last. It's like your first and last name for polynomials. Fun. Let's look at try number 1, A and B. Please name each polynomial based on its degree and number of terms. See if you can get it by yourself. Come back when you're ready for answers. Okay, are you ready? So how many terms does negative 2xy squared have? Just one. That negative isn't a subtraction. It's a negative sign, right? So that's just one term. It's not separated with any other terms. So you will have a monomial. And what is the degree? X has a degree of 1, Y has a degree of 2. So 1 plus 2 is the degree of the monomial, which is 3. So cubic monomial is the polynomial name for A. Part B, how many terms does this have? 1, 2, 3, right? 1, 2, 3. And then look at the degrees. X has 1, Y has 1, so that's degree of 2. X has 1, Y has 1. So the greatest degree of the monomials would be 2. That is your degree of polynomial. So if you have a degree of 2, that would be quadratic. So quadratic, if you have 3 terms, what is it? Trinomial. So quadratic trinomial would be your answer for B. Check your answers. All right, let's look at example 2. Write polynomials in standard form. What is the standard form of the polynomial 7x minus 5 minus x cubed plus 6x to the 4th power minus 3x squared? Wow, that's a long polynomial. The standard form of a polynomial, what is the standard form of a polynomial? It's the form of a polynomial in which the terms are written in descending order. Descending means go down, according to their degree. So look at your degree of your monomials in your polynomials, right? And then you're gonna write down the greatest degree first to the least degree. So here, degree 1, constant, degree 0. Negative x cubed, degree of 3. Fourth, degree 4. Degree 2. So 4 is the greatest degree. So you're going to write 6x to the 4th power first. That is your first term. And then minus x cubed. And then minus x squared. And then plus 7x minus 5. What if there are terms that have the same degree? Then look at your variable and see which comes first alphabetically. So if the degrees are the same, you usually put x first and then y next, okay? And the standard form of the polynomial here would be 6x to the 4th power and so on, okay? Let's look at try number 2, write each polynomial in standard form. See if you can do it by yourself. Pause the video, come back when you're ready for it. All right, did you get it? So your biggest degree is the second term, right? So negative 3x cubed plus 6x squared plus 7 would be your standard form for part A. Part B, your third term is your biggest degree. So 8y squared plus 2y minus 3 would be your standard form of this polynomial in part B. Check your answers, see if you got it right. If you did, good job. Let's move on to the next page. Example 3. Add and subtract monomials. How can you use the properties of operations to combine like terms and write this expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form? You can also use algebra tiles to model the expression. So if you have the x tiles and the x squared tiles, whatever coefficient you have would be how many number of that variable you would have, okay? So 4x would be 4 of these green tiles. 3x squared would be 3 of these blue tiles. 2x, 2 green tiles, and then 1x squared, and then 5 constants. 5, 1 tile. And then you can add the like terms, right? What are the same tile? What are the same colors? You can add the greens together, you can add the blues together, and yellows remain the same. So altogether, you have 4 blue tiles, which would be represented as x squared, so 4x squared. And then altogether 6 green, so 6x, and then plus 5. That would be your simplified polynomial for your polynomial in the beginning. And then you will write them in order of degree. So the standard form would be 4x squared plus 6x plus 5. So if you have a like term, if you have like terms, you have to combine them and simplify in order to write them in the standard form. Okay. All right, so let's try number 3A and B. See if you can combine like terms and rearrange them in standard form. Pause the video, come back when you're ready for answers. So if you combine the like terms here and write in standard form, what do you get? If you add 4x squared and minus x squared, 4 minus 1, if you don't have any coefficient, that means you have 1x squared, right? So 4 minus 1 is 3x squared. That is 3x squared. And then 3x, negative 3x, if you subtract these two, you get a 0. They're the opposites, right? So it's just 3x squared. Okay? Part B, you add the like terms for these two. And that's the greatest degree. So 7 plus 5 would give you 12y cubed. And then the next degree would be negative 3y and negative 2y. You add the like terms, you get minus 5y. And then your constant stays the same. So 12 6y cubed minus 5y plus 7 would be your standard form. Okay, let's look at an example for adding polynomials. How is adding polynomials like adding whole numbers? How are they different? How are they similar? Consider the expressions 123 plus 405, right? You add each place values together, right? The ones together, the tens together, the hundreds together, and then that's your sum. It's similar to add polynomials when you order them in standard form, and your greatest degree, you order them by degree of each term. And then you add the like terms for each polynomial. So x squared plus 2x plus 3 is one polynomial. And then you want to add another polynomial, 4x squared plus 5. You can add the like terms for the degree that's the same and also the variables that are the same. So the same terms would be x squares here. So x squared plus 4x squared would be 5x squared. 2x is just 2x. 3 plus 5, you can add the constants and get 8. Do not add different terms. You have to add like terms. Okay? Before you add polynomials, the terms must be aligned with like terms so that you're not making mistake and changing your polynomials. Okay? So it's similar and different in these ways. So next page. What's the sum of 4x squared plus 2x minus 3 and 3x squared plus 6? If you want to add them, you align the like terms and then you add them together and then write them in standard form. Okay, you can add horizontally. Just make sure you group them with the like terms and then you can add them horizontally. Okay, vertically, horizontally, it does not matter as long as you have the right answer and you follow the same properties. Let's look at try number 4. You're going to simplify, write each answer in standard form. Make sure it's in standard form. Please pause the video, come back when you're ready for answers. So, if you look at part A, you're going to add the like terms and combine the terms that have x in it, right? So 3x squared would be the same. And you have x and you add 9. That is your answer in standard form. You simplify and you write it in standard form. Okay? And then part B. You have negative 2x squared. There are no like terms for that. And then you add 5 and 3x. You have 8x. And then you add negative 7 and 7. And that's 0. So that is your final answer. All right, now let's look at example 5. Subtract polynomials. How do we subtract them? It's the same. You're going to subtract each term. So make sure you're not just subtracting one term when you're subtracting polynomials. When you're finding the difference between two polynomials, you're subtracting the entire polynomial on the second polynomial, okay? So if you have a parenthesis here, that means you're subtracting this term, you're subtracting that term, you're subtracting that term. So then you distribute the negative sign to each term before you add them, right? And then you can add the like terms, and you do the same thing. How do you subtract horizontally? You group them with like terms together horizontally, and you do the same thing. Just make sure at the end you have the answer in standard form with the greatest degree term first and then your constant, if you have one, in the last. Okay? So the difference, just make sure you add all the terms of the second polynomial. All right, let's try number 5A and B. Pause the video and come back when you're ready for answers. Okay, are you ready? All right, so you're going to subtract negative x. What does that mean? If you subtract negative x, that means you're going to add positive x, right? So you're adding positive x and you're subtracting 4. So this could be rewritten as 3x squared plus 4x plus 2 plus x minus 4 without the parentheses. And then you add the like terms, you should get 3x squared plus 5x minus 2 in standard form. All right, part B. You subtract 4x squared, you subtract 6, and altogether you should have negative 4x squared minus 5x minus 12. Okay, x squared doesn't have a like term, so negative x squared would be your first term. All right. Now, application example 6. Apply polynomials. An engineer is reviewing the layout of a solar farm. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. What is the total area of farm's solar panels? So if you look at the picture, you see the solar panels. The total area of the large solar panels is represented by this polynomial. The total area of the small solar panels is represented by this polynomial. And then the total area of the medium solar panels is represented by that. So you have a lot of polynomials here. What is the total area using your polynomials? You don't have to figure out the x yet, okay? You don't have to figure out the x. Just write it in polynomial, in an expression. So you're just going to add all the expressions, right? Because the total area is all the areas added up together. So basically, you just add the polynomials, combine the like terms, and simplify, write that in standard form. So the total area of the solar panels is 69x squared plus 680x. And x represents the width in meters of each solar panel. So your answer is this, and labeling what your variable means is very important. All right, let's try number 6. What expression models the difference between the total area of large solar panels and the total area of the small solar panels? So the difference between the first polynomial is the large solar panels, and then the small solar panels is going to be subtracted from the large ones. See if you can solve the difference by yourself. Come back when you're ready for answers. Okay? So again, you're going to find the difference. So whatever your the area of the large panels is 32x squared plus 384x. You're going to subtract the area of small panel, right? So that's 4x squared plus 24x. And then you have 32x squared plus 384x minus 4x squared minus 24x, because you're distributing your negative sign, the subtraction, right? Because we're adding the negative terms, or you're subtracting each term. And then that should give you 32 minus 4, 28x squared, plus 384x minus 24x, which is 360x. Okay? So that is it. Your answer is the polynomial. Okay. Just make sure you follow the steps one by one and combine the like terms. Let's summarize our lesson. We learned adding and subtracting polynomials. And we learned some vocabularies. Please remember how to name them and categorize the polynomials according to their degrees and the number of terms. And make sure you know how to write them in standard form. So make sure that you know in standard form, monomial terms are written in descending order, not from ascending order, okay? And their names come from the number of degree first, and then the number of terms after that. So this one would be a cubic with the term or with the degree, and then trinomial with the term. Okay. And adding polynomials, subtracting polynomials, you just have to add the like terms, subtract the like terms. Just make sure you're distributing your negative sign when you're doing subtraction. All right, that was lesson 1, adding and subtracting polynomials. We'll continue with lesson 2, multiplying polynomials in the next video. Bye.